Hi, welcome to the 6502 show. Hey, I got a special edition for you. This is going to be, well, hello. Hi, welcome to the 6502 show. I've got a 6800 edition special for you this time. We're going to add a little bit of memory to the monster, so stay tuned. No home computer is complete without some kind of storage. Now, back in the 70s, of course, that was a cassette deck for the vast majority of people, and if you were so lucky or had the means, you probably went out and got a disk drive as fast as you could. I do not have a cassette interface for the Monster 68. It would certainly be easy enough to do. The schematics for the AC30, the Southwest Technical Interface, that's available. You can see the schematic on DRAM. So go check that out. Let's look around for something else. I had followed Daniel Tuffison's 6303 homebrew computer project for a while. He built himself a 8-bit compact flash interface. And one of the things that he said about it really stuck with me and gave me some hope. And he says, the old 8-bit mode from the XT days is back. This makes the hardware interface ridiculously simple, as the card acts just as a regular Intel bus peripheral device. The phrase ridiculously simple, that's for me. That's what I need. And I thought, hey, this isn't hard at all. And looking back at Daniel's schematic, really all you're doing is hooking up a couple of address lines, hooking up the data bus, and pulling up some lines and grounding some other lines. That I can do. So I made a rough sketch on some notebook paper and thought, I gotta put some more RAM on here because I'm gonna need a little bit of room for some type of operating system, hopefully Flex 2. And while I was at it, I sketched up another card, hoping to put a VIA and a video chip into the monster. We'll see if that works out or not. So from there, it was time to make a schematic. I pretty much followed Daniel's design. I added a little filter on the read line coming in from the bus because some guys in a Z80 forum had said that this was smart and allows you to use a wider range of cards. So I thought, why not? Can't hurt. Finally, it was time to put my design one-to-one on some graph paper. It never really turns out exactly this way, but much better than a, rough pencil sketch in a notebook. It was time to put the thing together. So I first, of course, had to order a CF card adapter, and I got one right here from Proto Advantage, one of the few places in North America where I could find one that was already put together and ready for through-hole construction on 1/10 of an inch spaced holes. So I got the adapter, plugged it in, and started soldering. The reason I went with this design is because I'm not going to do surface mount stuff. It's just too tough. My hands aren't steady enough. My eyes aren't good enough anymore. So let's just leave it to some lovely machine-produced piece of kit here, and that gets us going. Now on the back, you'll notice how far the pins stick out of the back of the card because this is designed for wire wrap. I just went ahead and soldered on, but you could wire wrap if you wanted. It's really convenient. It's really easy to do. I know some of you guys like to do the wire wrapping. Anyway, I finished up the card, and here's what it looked like. Pretty simple. I've got a little 138 chip in the bottom right corner that's handling the addressing. I've got off my bus, I have the string 8000 line feeding in to the 74 LS138. And out of that, I'm simply decoding 4K blocks. The 8000 area is where I have my ACIA now and will have my 6522 VIA chip. That'll reside right at 8,000. And this drive resides at 9,000. So that works out just fine. Instead of doing some complicated extra addressing, which, I could have done. I could have put it at 81 or 8080 or something, but this was just simple. I'm not going to use that area for anything else anyway, and I can always change it. Simple enough to do. It's just, adding a few wires, a few lines here and there. Well, I also needed some RAM, as mentioned earlier, so I whipped together a RAM card and slapped in a 40-pin socket so that I can put my 6522 in there later, and got some output pins for the A and B ports of that. We'll get to that someday, maybe. Who knows? And in case you're interested, here's the back of the card. Woohoo! You can see where I had to Dremel out part of the card to make the pins fit, the header pins. Easy enough to do. With the card interface built, it was time to test it. And Daniel had provided a program called CF Test on his website, and it was trivial to make it work with my system. So you can see here, Daniel's monitor equates, or wherever he has his monitor in his 6303 computer. Easy enough for me to change to the more familiar SWTBUG/MICBUG vectors. And that's what we have going right there. He had placed his card at 8060. I have placed mine at 9000. And left the start alone. And everything else just as it was. Daniel's software has a buffer at page 10. I didn't see any reason to change that. So that's just where I left it for these initial tests. Okay, let's load up Daniel's CF test modified for the monster and see what we see. Let me turn it on. All right, monster's alive. There's SWTBUG's $ prompt. And as we saw, the area of string 1000 is the scratchpad buffer area for the test program. So let's just take a look into the memory right there. Caps lock is helpful. And let's see, there's some stuff in there. Just looks like random crap. How about we do this? Let's just drop some zeros in there real quick. Yeah, 16 ought to do it. Okay. And 01 just to let me know that I ended something right there. Okay. Let's go load Daniel's test program to see if the card will get read. Boomsies. All right. A quick jump to 0100, where our test program is, should tell us if the CPU can read the card and put it into memory. Make sure everything's all tidied up here. Here we go. Whew, success! Read the card. It read its serial number, the firmware, and its model. And it gives us the size of this card. It's a 64 megabyte card, 2 partitions, and there are EA of them. That's what, 223? Well, I'll do the math and flash it up on the screen. Okay, so if I press I get that again. And now we want to read in a sector. So I'll tap R. And let's read in 0000, track, say, OE, and sector AA. Okay, it did it. Let's see if we have some transfer of data going from the card into RAM. So we'll quit, and then we'll take a look at string 1000. Most definitely different. So there was data transfer that went on. And you can see that all of the odd numbered bytes are FF. That's interesting. And that is true to the true IDE 8-bit, true 8 mode, whatever it's called. That mode only reads and writes the even bytes of a sector. And a sector on this card is 512 bytes long. So each sector for us, because it's only going to read half of it, is a page of memory. Yeah, not bad. So we will need 7F pages of memory in order to fill up, we could fill up all of our user RAM and stick it onto the card. And actually, that's what we're going to do. Well, once I had the interface built, which is great, I mean, that's way cool, and I got it to pass the initial tests that Daniel had put together in his CF test program, I did notice some odd things. But I'll tell you about those in a minute as we build the software that makes this thing usable. Well, I wanted to have a little bit more thorough testing. So I wanted the ability to immediately view a sector that's read off the card, and also the ability to write some of my own data a sector at a time onto the card. And for that latter issue, I borrowed a little bit from Daniel's Quick File program and modified that to create a write program. And it's going to read in a page of my data and store it into the 512 byte sector of the card. I've also moved the program out of user RAM. So we're going to stick this into our auxiliary RAM at A800, and we'll have our data that we want to read and store onto the card at AA00. This is where I discovered the error in the 64 megabyte CF cards. First things first, let's load up some data real quick. Get the debugger running. Go to it. And let's fill our user area with, let's say, the byte AA. Done. We can take a quick look at that. Filled with A's. Fantastic. And after it, bunch of stuff. And before it, bunch of stuff. Okay, groovy. Now we can exit our debugger, and we'll load in the new modified version of CF test. Alrighty. Let's jump to it, shall we? Although it's usually helpful to jump to the correct starting address, so let's do that. Okay, here's our flash card. We know our data is in AA00. We're going to write it to a sector. Let's do just that. I want to write that to, let's say, 0001. How about CCDD? Written. Okay, let's read that back. 0001 CCDD. Looks great, but check out that last byte. It did not get written, and that is a problem. If we want to save anything bigger than 255 bytes, we're going to run into bad data, and that's going to screw everything up. So I had to come up with a workaround, thinking that, well, it's got to be my design, right? It's just so simple. It's got to be a timing issue on the bus, and I just didn't do it right. Well, after getting Lil File running to my satisfaction, and I shared it with the 6800 Facebook group that I belong to, one of the guys came up with a brilliant little piece of information. It turns out that he had used these exact same cards before in a project and got a stack off eBay just like I did. The hitch was Cisco had a manufacturer at one point that just the cards didn't come out right, but some of them are. And there's not much way to know. The only way I could figure out was where they were manufactured. These right here, these were all made in the US. Bad, 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 bad. Bad. Now these over here, made in China, good. Good. As I thought about the kind of file system that I wanted to put together, I originally, Flex 2 was the goal, but that wasn't going to happen. Way above my pay grade. Even Daniel's quick file was pretty complicated, and there were some 6303 opcodes that you just don't have in a 6800 or 6802. So I'm sure it can be worked around, but again, an area that I need to learn more about before I attempt something like that. So I took some pieces I did understand from Daniel's quick file, and as mentioned here and confessed to, I modified, mangled, and transmogrified his wonderful code and made it work on my machine. And the way I went about it was to only write half of the page at a time and put that in the top half of every sector on the card. So per track, instead of having FF number 255 pages so that I could save 64K in every track, what I'm going to be able to do is save 32K in every track. Well, that's fine because that's the entire user RAM. And the way to put this together for me, the simplest way, was just dedicate a track per program or state of the machine, if you will. We're going to save the entire RAM area from 000 to 7FFF every time. And we're going to take, though, a very inefficient route to do it. So we're going to read half of a page of user data at a time, store it onto a sector, and then go get another one to finish the page. We're going to do the first 128 bytes, then we're going to do the other 128 bytes and write those, and we'll just keep going until we've done everything. Here's the actual writing routines. These are pretty verbatim out of Daniel's code. Thanks, Dan. And then we write out the catalog area where it's going to be. We give it a file name, put it in the catalog track, and save the sector number it's in. Now, I know what some of you are thinking, how horribly inefficient this is. You have a 64 megabyte CF card, and you're only using a quarter of it. And you could use so much more, even with the regular even byte only reading in an IDE setup, true IDE. And it's true, but you know what? This serves my purposes. It can certainly be improved upon. And even though I'm going to only use a quarter of it, think of it this way. In 1980, could any home computer user, especially somebody who was using something like the 6800 line, could they have imagined having two 8 megabyte hard drives at home? I mean, that's pretty good. I mean, no one ever dreamed of having that kind of storage at home in those days. And on top of everything, most folks didn't even have a floppy disk drive. This system works 9 times faster than a Commodore 1541, albeit a notoriously slow disk drive, but hey, I can't complain. I've got a neat little system that saves my memory, saves the state of the machine, and works for me. But please feel free to improve upon it. All we're going to do is give this thing a little shakedown right now and show you its quite limited but, functional capabilities. So I've got this in ROM now, and I have SWTBUG's D command mapped to Lil File. So rather than booting Flex, it just jumps right in. And there we are. Now, let's see what's on partition 0 of this disk. We'll use the catalog command.
Now watch carefully, or you're going to miss all the excitement.
Whoa!
It takes a while to read through the catalog sector because I've got a sector dedicated to each track. So this tells you the track number that the program is on. If I wanted to run, say, Domino Train, I would type load, and we're on partition 00. And I want to load in track 31. Magic's happening. That's 9 seconds for 32K. We're done. So our program is loaded in. We can quit. And now, because I know it's an Altair Basic program, because on the catalog it says Domino Train AB, I have to just jump to the warm start for that basic. 0007. Okay, run it. And there's Domino Train. We can play it if we want, but we're not gonna this time. Another thing we can do is save our work, and we can give it file names. So let's say that what we have in memory, let's say it isn't Domino Train, something else. It really doesn't matter. We'll just save the thing. So we'll call it the thing and test. 16 characters max, but that's it. I want to put it on, let's say, partition 0001, and I would like to put it on track, 2F. And the magic's happening again. So that'll be there for us next time. And if we want to see what's on that sector, as soon as we're done here, all we got to do is to verify that it got written, get our catalog again, and we put it on track 2F. Oh, that's right. It's finding it. I don't have to type 2F. I just want the whole partition. And that is the only thing on this, on that particular partition of the drive. Format, all that does is it wipes out track 0 of a partition, because that's where all the catalog information is. Daniel's good old info command is still there. And other than that, we can quit. That's it. That's all it does. So there you have it. Lil File. It files away a big pile of RAM, and it'll retrieve a big pile of RAM.
Well, that's about it. It's about as simple of a file system as you can get, and there's plenty of room for improvement. I expect you to have at it. Okay, thanks for watching the 6502 show, special 6800 edition, and I'll see you again when I see you. So until then, take care.